Thank you everyone for joining. This is our 8th Insiders Call. We have a packed agenda today, as always. So we have our lightning talk, and then we're going to jump into a discussion. It's going to kind of build on some of the themes that come out of the lightning talk and think about strategies to identify and mitigate potential risks or threats. And then we're going to spend the rest of the call talking about security practices in place for ODK, some best practices to think about. And then we're going to skip the product updates for this call. I don't think we're going to have enough time, but if we don't, we have the slides so you can look at those afterwards, or of course look at the roadmap. And then, as we did last time, we're going to stay on after for some after hours. If anyone has spicy questions, you can actually ask spicy questions throughout the call, but we'll stay on after if anyone has things they want to talk through. So our lightning talk for today, our guest speakers are Chrissy and Callum. They're going to be talking about a system for capturing fingerprints during data collection and demonstrating how that works with Collect. So if you have any questions as they're talking through things and demoing, please add them to the chat. Let's make this a discussion. So I'm going to hand it over to Chrissy and Callum. Take it away.
Can I go first, Cal? Because I'm going to speak
very.
Yeah.
So hi everybody. This is just really to contextualize this. So this project started in about 2018, and it came out of some of the work that I do around global health and clinical trials. And basic problem is that there's a billion people who live on the planet who don't have any way to identify themselves. There's no passports, papers, ID cards. So if you have a situation where you need to see a person twice and you need to confirm their identity in between those two time points, it's very hard to do that if they don't have anything that they can show you to show that you're the same person you saw before. And in a medical setting, that's very important. If, for instance, I give you one vaccine in 2019 and then I'd come back in 2020 to give you a booster or a different vaccine that complements the first, if I can't confirm that you are the same person who was given the first one, it might be medically unsafe to do the second. And then in the context of a trial where you're trying to prove that a new drug works, if we haven't got concrete evidence that you gave both doses to the person, then you can't really properly evaluate that drug. So there's a couple of use cases. It all centers around this thing that, ordinarily would trust somebody just to show you a card with their ID on it. But when people don't have that, we need to start looking at things like biometrics as a way to get that cast iron confirmation of identity. And this also leans into things like rights of participant access, when people want to come and get their data from you to see the things you've done with their data. And it also supports low literacy and zero literacy settings, because many people can't sign their name to a document. So being able to provide biometric participatory stuff is quite beneficial to those who don't have other means of participating in that process of giving you consent to collect and then look after their data. I'll hand over to Cal because he's the wizard behind making this an actual thing rather than a use case. And I'm really looking forward to seeing this as well.
Hey everyone, not a wizard. But so basically, with all that in mind, I think Chrissy came to me in it's like 2020, right? So right before the pandemic, I remember. Because I remember you saying to me, this might be quite a big deal. And we basically looked at initially seeing if there was a way to integrate biometric data, namely fingerprints, into Collect itself. But the problem there is you'd have to choose which device, and Collect would have to be kept up to date with whatever SDKs the scanners you use, and they would also have to you might have to incorporate loads of scanners. So we decided what we would do is build an external app. So for those not familiar, ODK Collect can integrate with external applications. That's the kind of Collect terminology for it, but it basically allows you to have a string widget or a number widget or an image widget, and you can press the button and it goes to the app. The app does whatever it needs to do, and then it'll hand the data back to Collect. I'll show how that works in a forum afterwards, but I'm going to show this actually like working first. And so the idea is that we build an external app that integrates with a scanner. At the time, it was a little grey device called a Mantra, which I've put in a box. I don't know if you have one at hand to show, Chrissy, but you can show the other one. But then I recently worked on another project to add support for a different scanner and a custom tablet. And then thirdly, Chrissy has just sent me, so he's going to show you the original scanner. Look at this, like, that's cool. So that basically just USB plugs into a device. Yeah, look at him demoing it, brilliant. And then the current one I've been playing with is this. So it's an Express BioMini Slim 3. They've all got really, really good names, these scanners. So yeah, I'll demo it just like Chrissy did. I've just, as you can see, it's just plugged in USB. This is a Pixel 4a, so kind of an old phone. And what I'm going to do is just show you this kind of working. So do a share here. Okay, should be able to see everything. Say, can someone confirm my screen is on the screen?
It's just loading or just
Okay.
warming up. Interesting. Do you want to try again? Or can anyone else see it? No.
As they say, never do a live demo of anything.
We just tried.
We just tried it right before.
Just tried this. Is it happening?
No.
No. Whilst you're fiddling, I mean, I can add a little sort of more background to this. So in the work that my team does, we often consent people to share their data and sometimes specimens from their body. And historically, we've used ink pads, and they will put their thumb on an ink pad and then stamp it on. And most of the regulatory bodies worldwide will recognize that as an effective way to collect consent to do one of these data sharing processes. When you actually take those smudgy fingerprints of ink and try to compare them to anything else, it's essentially a fruitless and entirely pointless process. If somebody came to you and gave you another inky stamp, you wouldn't be able to match and get any kind of metric on whether it's likely to be the same person or not. So they are, to all intents and purposes, after that participatory process of actually doing the stamping, there's no proofs involved. So this conceptually is a step forward because it allows us to collect the same way, but then eventually actually do something with the data in a practical and useful thing that protects the rights of the participants. I'll stop speaking now. Over to you, Cal.
Yeah, so hopefully you can, for some reason it won't let me share my entire desktop, which is super annoying. But I'm just going to share my the app I'm using, and then also I'll switch later to the actual forms that I want to show you in XLS form. So basically what I've got here is a little flow. It uses entities because I'm working on entities right now in Collect, and I can't think of anything that isn't entities basically. But what we're going to do is we're going to register a person using our person registration form, and then we're going to take both their thumbprints, right? So we'll go through this. So I'm going to register. I'm going to call this Mr. Pinky. Oh no, I'll call this Mr. Index actually, because I'm actually going to cheat and use my index fingers instead, because I've already registered my thumbs with a different entity. So I want to be able to demonstrate this working and not working. Okay, so I'm going to scan my thumb. I'm actually going to scan my index finger just for like value. I'll show you this actually happening. Boom. You'll see I'm using the masked appearance so that you don't actually see my fingerprint templates, because this is being recorded and that's a little scary for me. This again, my left index finger. Boom, cool. So what that's capturing is a big, massive string that is essentially like, it's called a template of my fingers. It's not my actual fingerprint. It's like a hash of my fingerprint. And that's enough information to then match against later, which we'll show. So I'm going to send that. Cool. Refresh. Now I'm going to follow up. And so the idea is, this is really like, this is just a toy form basically. But the idea here is it's a form that lets you select from one of your people and then it will use the fingerprint matching to verify you've made the right selection, right? Basically. So we'll go for Callum. Show you this. Okay, so now what we're going to do is verify myself. So this is what I made earlier, where I registered my thumbprints. What's cool about this is we're using a way of integrating with the app here that allows us to, I can basically scan either of my fingerprints and it'll work out if it's me from those fingerprints. So scan my thumb. Oh, bad scan. Cool. And now if I go there, it's going to ask me how I'm feeling. And then just the demo, if I scan the different finger. Unfortunately, I only have fingers that belong to me, but these are not the fingers I scanned. Yeah, so we'll get 14 there. And then if I go there, so that's just a simple constraint, right? The threshold I'm using is 40 at the moment. Chrissy, is that like a good threshold? I think it was, right?
It
You
depends
higher?
what you want to do. This is a classic diagnostics issue. Depending on what you want to use it for, you can change the threshold. So the higher it goes, the more likely it is that it's a true positive, and the lower it goes, the more likely you are to get some more positives, but more false positives as well. So you just need to pick the right number for your purposes. There's no correct answer, but we did write a paper on which we found a pretty good answer, I think, which was somewhere around 80 or something like that.
Yeah. So the number, I just saw a question. The number is not really a percentage match. It can go higher than 100. It's a score that comes back. I actually don't know much about how that scoring is derived, but it's essentially, as Chrissy says, you tune for your use case what exactly the threshold you need is. So it's always good to test with these things, because also different devices and different environments will give you kind of different scores. Like if you've got lots of people with grubby hands, you're going to get worse scores, for instance. So hopefully that will make sense. It's just very simple flow, and you can see where you're matching there. So I want to show you the actual forms now. So I'm going to do stop sharing, and then I'll share the browser, which hopefully works. Does that work?
No, not yet.
Oh yeah, unfortunately. And just to reiterate, so what happened when Cal verified his identity then was that the form fed both of the thumbs into the app, into the standalone app, and then the new fingerprint was then tested against both of those fingerprints. So if you collected all 10, it would scan against all 10. It would take longer, obviously. So there's going to be a use case where you want it to be quite quick, and one where you want it to be more thorough. So you know, if you were doing something where it was like crime scene investigation and you had all these things in a database, you'd probably be wanting to scan against all 10, and you might accept a lower threshold because you might want to find potential matches rather than guaranteed matches, so you could go and interview those people.
Is my screen, my browser's not sharing? Okay, I don't really know as much I can do about that, because it's just I can reset everything, but
So weird, it was just working.
Would you like me to
I can share the forms, I guess.
Let me share them. Just give me 1 second. I think I've got them open. And then you can send next slide, please.
Thank you.
We want registration first, presumably.
Yeah.
Okay, can you all see
Thanks,
that?
Chrissy.
Yeah.
Cool. So this is the registration form I was using. So you see, very, very simple form. So we just get the full name. You'll see the save tos, which are what creates the entity, which makes it for the select one later. I won't go too much deep into that. Hopefully people are familiar with entities, or just treat it as magic if you don't understand it. You'll see the important part here is we're using this appearance, which is a strange place for it to go, but it's just how it works in XLS form right now. But we're able to basically say to collect, oh, you get this text information, you get this from this ID here. So it's like X colon, and then you'd have the app ID there. And then you also have different actions for different applications. So you'll saw that the app we used, Keppel, supports scanning and matching. So next slide, please, for the follow-up. That's the interesting bit.
1 second.
I prefer this, actually.
And right,
okay.
make that bigger. There we go.
Yeah, brilliant. Okay, and so again, this is pretty simple. So we select one from file from the people that we've created earlier. And then you'll see what I'm doing here is I pull out the right thumb and the left thumb for that person using the very approachable instance syntax, which would be nice if there was a nice way to do this in XLS form. But we just grab the right thumb and the left thumb for the entity that we've selected, basically. And then if you scroll all the way back, we then have, to actually get the match and the verify, we use this multi-match action, which is a new feature in the app. And that allows us, as Chrissy says, to pass multiple different templates in. And then what Keppel will do, the app, is that it will compare the scan that I take to all those fingerprints. As Chrissy said, it's going to be like however many you pass in is going to be a function of how long it takes, basically, to do all those comparisons. But what's cool is it allows you to verify a person without having to like go, try your right thumb, do your left thumb, and it helps with things like, oh, they lost that thumb or something like that, and that's like a real problem that could come up. Is there anything else? Oh yeah, and then there's the constraint you'll see is how I did the verification, the threshold. And the constraint, this is an example of using the constraint on a match in the actual field in a form. I know when we first, the first context me and Chrissy were looking at, the thresholds were more something you were using in analysis, right? It wasn't really something that you were looking at to do in the field. And I imagine the field is much more sensitive what the actual value is. But the cool thing we'll see there as well is that the right thumb and the left thumb are being the actual right thumb and left thumb are put in the form, but you could also return the scanned finger as well. And what that would let you do is later basically do comparisons and check that everything actually worked in the field, right? That like the data wasn't faked. And the cool thing about the ISO templates, the way the thumbprints and the prints are turned into a hash basically, is that they're very, very hard to fake. So they give you a nice degree of like, okay, this was probably a real person. Like if this person had a finger that quite highly matched this other finger, so it was probably the same person.
Yeah, and I think an important thing to note here is that you can't take a hash and reconstruct an image of a fingerprint.
Yes.
So the hash is created from certain points, branch points in the fingertip. And so you couldn't ever turn it back into a fingerprint, which there is a malicious use case for in some settings. So
of course,
collecting it in data is also obviously more data efficient. So you get smaller files than attaching images.
Yeah, and that was very important that it wasn't something, because it just felt really scary, the idea of recording images as part of this work. So having a hash format was much better. Cool. I think that's everything.
Should we need to acknowledge the funders of this. So the initial work was funded by the UK government as part of its aid program, as part of the UK Vaccines Network. They paid for the first part.
We have a few questions in the chat. First one is from Dan. The decimal question is where the scan app happens in the follow-up. Want to answer that one first?
Decimal question is where the scan happens in the follow-up. I don't think I understand that.
Or just maybe you could in the follow-up form, there's the
Thanks.
I was looking at the different lines and I didn't see which one, it wasn't immediately clear to me which one was the scan of the finger in the follow-up form.
Oh, in the follow-up form, so the form we showed, we don't actually we don't currently return the scanned finger to the follow-up form. It just returns the score to the decimal. But you can use the like, I don't know if you've seen them, you can have external apps that return multiple values to a group, like a field list group in Collect. And that means you could return like the score and the template that was like the winning template, and also like quality scores and things like that as well.
Which I think we probably need to do, right?
Do you scan the finger in the form? Do you scan their finger in the form? To see if it's a match? Yeah. Which line was that happening on?
Oh, so that's the multi-match action. So if you go back to the follow-up form. Yeah, so basically that multi-match, when that goes to the external app will scan, like I scan my finger using external app, and then the left thumb and the right thumb that are being passed in from the entity, they get compared against that scan. Does that make sense?
the decimal question is the one that opens the external app.
Yes,
And
it's kind of
yeah.
like that's handling like the whole flow there. It's quite a busy flow.
Yeah,
Got it, thank you.
ideally it should probably return both the matching score and the template, because for veracity later, we're going to want to be able to do at least a subset where we sample out and just check that the matching scores are what they say, so we haven't, to ensure that we've got reproducibility.
Yeah, I think in a lot of real contexts, people also like to have, there's another value you can get back called an NFIQ score. That's, I believe, an FBI defined like quality score for a fingerprint. And I think in a lot of contexts, you'd want that as well. So I use the simplest version that just passes back a decimal for this, so the form wasn't too busy. But I think in real life, you would often use the multi-return version, which uses a fieldless group.
Cool. We have 2 more questions, but I think we only have time for one. Saad, I see your hand up, and then maybe Florian, we could answer you in the chat. Saad, do you want to ask your question first?
Yes, thank you very much. I have a bunch of questions, but I'll keep it short. Maybe we could have communication with Chrissy later on email. The scanning of fingerprints. The fingerprints are stored in ODK Collect or the Keppel application database.
Oh, they don't. The app just scans them and then gives them back to collect. There's no data storage in Keppel at all.
So how does the matching work? The number matching that you're doing?
Yeah, so the matching, your collect basically gives Keppel the fingerprints to match against, and then you scan, and then it does all the work and then hands it back. It doesn't have like the list of people in it. That's collect passing that data in.
Right. So if I have a pool of like 10,000 people, all the data of everybody's fingerprints would be loaded into collect, and this would be exchanged with Keppel, and all the logic would be done there, right?
Yeah. So like in the examples I had, I was using entities to store the people and their fingerprint data.
Okay. Just one more priority question. The hash of fingerprint that you're saying, how small is it? My line of question is that I want to fit the data into an SMS, because most of the projects that I'm doing, they don't have internet connectivity in Africa. So, but the SMS is working. So is it possible to bring it down to like 160 characters or 320 characters? Because this is kind of the payload of 1 or 2 SMSs.
No, as far as I'm aware. I think it's I think there would be some security issues there anyway, texting people's fingerprint templates around. So that doesn't necessarily have the same protection that ODK has. I would feel very worried about doing that and why we would want to do that. I think sending the scores back might be something to consider.
Yeah. This is one of the approaches. And because I've gone through your project, and there was some server-side scripting as well, which was doing the matching for the fingerprint. And my whole working was to port the fingerprint to the server somehow, so that the matching could be done.
Yeah, so that's very similar to what we did with the first version of this software, where we did the matching on a computer later. So to confirm, for instance, in my clinical trial data set, that person A was still person A 6 months later, we did computations with the templates which had just been sent in one direction to the central server. What Cal's now developed is a system where, using entities, those fingerprint templates can go back to the device and then can be tested against live in the field. Does that make sense?
Okay. Yeah, sounds good. Can it be a security risk, having so many fingerprints loaded in collect?
Can
I feel like that's a great segue.
Yeah, can I take over from here?
Yes, please do. And we have time at the end as well, like to keep going with this conversation as well.
Yeah, these are great questions, and it really is a great segue, because we said our main our post lightning talk topic is security and privacy, very related to what Chrissy and Callum just shared. So thank you both so much for going into detail there. Before I switch into that, I just want to say, I hope that one of the things you're getting out of this is maybe if collect doesn't do exactly what you need, there could be a little external app that you could build or that you could have built to help with whatever function that you require. So if there is a use case like that where you're like, oh, the functionality isn't built into collect, but maybe it could be done, definitely post on the forum about it and let's explore what we could do.
Can I just quickly butt in there, Lynn? Just to say, like, so that app we built, it's open source and we'll link to it at the end. But one of the whole points is that it should be really easy to add support for new scanners. So if like it only supports 2 scanners at the moment, if it doesn't currently support a scanner, it's something that could probably be added through either contributions or like talking to ourselves about adding that.
Yeah, thank you. So let's answer Saad's questions. We want to talk about security and privacy and how to think about security when we're working on an ODK project. And so we wanted to start by doing an exercise based on what Callum and Chrissy just shared, introducing the idea of threat modeling. So maybe that's familiar to some of you, maybe it's not. The idea of threat modeling is really, let's find out what possible threats there are to our system. Usually they're security threats, but they might also be more like integrity threats, threats to the validity of our data. Like Chrissy started out by saying there was a threat to the validity of his trial. This is part of the reason that they came up with this fingerprint matching system. It's really important to do, so we'll try to give you a few tools. One of the resources that I really like is this threat model manifesto. It's really simple. So you might think security, that sounds really technical, but actually you don't have to have a lot of technical knowledge to be really good at identifying threats. And that's the key part. If you can identify what threats are, then you can do something about them. So the threat model manifesto suggests just asking these very simple 4 questions. What are we actually doing? So this is coming back to workflow mapping, some of the things we've talked about at other insider calls. Like, it's really important to be clear on what it is that we want to do, what data we want to collect, why. Once we know that, once we've kind of mapped out our system, then we can ask the question, what can go wrong? That's a very broad question, but if you just get in the habit of asking that question over and over and over again, you can really get to some important truths about your system and, kind of properties that you need to address. What are we going to do about it? So how can we mitigate those threats? And then doing some evaluation at the end. Did we actually do a good job? There are more resources linked in this OWASP cheat sheet that I highly recommend checking out if you want to go a little bit deeper, but this is enough. If you get in the habit of asking these questions when you're putting together a new project, you'll probably be in really good shape in terms of considering the security of your system. Here's an example of what goes a little bit deeper in that resource that we linked to. Some people, when they're thinking about what can go wrong, they have categories that they help to guide that thinking process. This is one that I really like, called the STRIDE model. STRIDE is just, it's an acronym to help you remember these kinds of threats. So you can see the first letter, spells out STRIDE. So you might think, what can go wrong? You can think, is there an opportunity of spoofing? So pretending to be somebody else. So this is the kind of thing that Chrissy and Callum are addressing, right? If you have to put in a fingerprint, that really reduces the opportunities for spoofing. Is there some kind of opportunity for tampering, somebody modifying data? This next one is weird. Repudiation. Could somebody say, oh, I didn't do that. It wasn't me. Is there enough audit data so that you can say what happened and what didn't happen? Is there an opportunity for information to be disclosed that's in a way that's not supposed to? Denial of service. Is there a way for the whole system to come crashing down if somebody tries to put too much data in, for example? And then the last one is elevation of privilege. Can somebody do something that they're not supposed to do within the system? So there are lots of these kinds of models. Again, they're linked from that resource. I encourage you to check them out so that can help you think about what could go wrong. Let's kind of talk about an example. We're going to simplify the workflow that Callum and Chrissy showed to kind of build on previous workflow conversations that we've had. We're going to try to identify risks and what we could do to mitigate them within this really simple workflow. And then hopefully this gives you ideas again to apply to your own workflow. So here's the basic, really simplified workflow that Callum and Chrissy shared. You know, if we were really workflow mapping, we'd go into much more detail. You know, we'd say like the data collector starts with consent, they show the fingerprint scanner. We'd go through all these steps, but let's go with something really simple here and just show, you know, there's a registration form, the template is sent to the server, the verification happens on the device. If there's a match, then the service is delivered. And then we can think about some of the threats that there are to the system. We do this by just saying what could go wrong. I bet many of you are thinking about this one, and I think this is kind of what Saad was getting at. So here we framed it as the leak of biometric data from server. But Saad, you were saying there's also an opportunity for a leak from the device. So absolutely, both of those are possible. What are some ways that we could mitigate that? Well, one big one that Chrissy mentioned is don't store the actual fingerprint. If you're storing a modified hash that can't be made into a fingerprint image, then that already means that there's not a lot of incentives for somebody to take that data, right? So that's one big piece of mitigation. But then some other kinds of mitigation might be, you know, you might want to really limit access to that server if you know that there's biometric information on it. You might want to make sure that you're reviewing the access log periodically, that all of your software is updated. All of these things are particularly important when you have sensitive data. Okay, here's another example. If there's an incentive for, you know, if let's say that the service I'm going to get, if I match my fingerprint, is a lot of money, then I'm incentivized to cheat in some way, right? So there might be a risk of individuals registering at the wrong person, maybe registering as multiple different people, so that you're disrupting the activity or that the wrong person is getting whatever the service is. How could we mitigate that? Well, maybe there's a way to verify another ID. Chrissy mentioned that's probably not possible in a lot of places, but maybe you could have somebody else certify that you are who you say you are. Maybe there's a phone number that can be collected. So here you'd have to think about what can we add to our workflow to mitigate this specific risk. So I want to open it up to discussion. Looking at these steps in the workflow, can you all think of other things that might go wrong?
So can I lead? Because I think that, you know, I like the description of leak of data from the device.
Yeah.
I guess, you know, the concern that Saad had, that you are preloading a device with a list of names and those fingerprints, or the templates at least. How hackable is the list through the ODK Collect app? I mean, could somebody who's adept actually just go in and extract that CSV?
That's a great question. So there are different aspects to that, right? There's one is sort of somebody loses the device. It falls on the ground, somebody picks it up. And a lot of that security we let the Android system take care of. So if you're using Android 10 and above, all of the data on the device is encrypted by default. And so you need to make sure that the device has a pin on it, and then it generally is very unlikely that that data would be recoverable. One caveat is some device manufacturers don't do the encryption in a fully secure way, so you have to be a little bit careful if it's very sensitive that you trust those devices. But the mitigation would be making sure that you're using a recent enough Android version that you have that encryption, making sure that you have a secure either biometric or PIN lock on the device. Saad, do you want to add something to that?
Yes, my use case is basically, you know, the donors or the project management, they just put one question in front of you, asking you that, you know, we are working on putting a lot of data on devices, especially the fingerprints. then the field staff, the projects that I'm working on, the field staff is allowed to leave anytime, and they don't really follow the protocol of returning the device to the ministry before they leave. So the natural question is that a phone goes missing with a lot of data. They may not be asking me who can hack into it, or how is it possible to do that. Maybe the basic question that comes from them is that how secure is it, whether it's easily breakable or not. I think you answered this as well, saying that Android puts the data in some encrypted form or something.
Yes, so you have to be you have the project in this case, you have to be really careful that you have the right devices. Like it probably wouldn't be appropriate to use data collector personal devices. In some contexts it is, but if the data is more sensitive, then it may not be. So yeah, you kind of have to go through what could go wrong at different steps. Yeah, who is likely to walk off with a device? What happens then? What could go wrong? And kind of keep pushing on that to decide whether it's appropriate to do this at all and what mitigations you can put in place.
Yeah, and if I just cut in as well, I think, the use of a managed device. So, for instance, I have a fleet of devices which my organization manages. They're locked out, factory reset. They're wipeable remotely. And I think, we are at this level where we're collecting biometric data. We are in the area of collecting highly sensitive personal information about real people, usually living people. That takes it out of the bring your own device context. I think, as Len said, it's a case where you are going to be using devices that are managed by an organization rather than bring, just the one from my pocket that I load 1 million fingerprints onto.
Yeah, other thing to add to that is because anyone that, if you have access to the device, then you have access to all the data on that device. So I think the questions come up before, and I think is sort of being alluded to here, is we can't protect that data from a person who has legitimate access to the device, right? Like the Android device can keep people who shouldn't have access to that device out, but if an enumerator has the passcode and can unlock the device, the storage is unencrypted, and someone could access that entity list on device.
Yeah, and I think partitioning the data is a very effective way to mitigate risk as well. So it's easy to set up 20 forms, each of which has, like, for instance, a regional list or a cluster list. So if you do get a leak from a specific device, it's more likely it had only a subset of the total available data. I think there's no setting in which I think it's reasonable to load, everybody in the country's fingerprints onto a bunch of devices. But I think it would be at the neighborhood level or even at the district level perfectly reasonable to expect that. I'm not sure the best way to manage that beyond having multiple instances of the form, which each has a different user.
One of the things that I was trying to do, I think I posted this on the forum as well, was in the initial days of entities, was to connect the data to the enumerator through some ID or something. So the idea is that if one field staff is going around in a village and collecting registration of multiple people, he should be having the data on his device. He should be having the data of only those people who are registered by him only, so that not everything is ported out to his form when when ODK Central replies back with the data. I haven't really seen the latest version of entities, but maybe it has been solved by now or not. I'm not really sure.
It's not yet, but that's very high. Yeah, it's very high on what we want to do. It's something that we are actively developing towards and trying to lay some groundwork to do. But Christy's right that now sort of the best approach for segmenting entities is to have separate forms, but we want to work towards kind of what you described, Sad. Maybe one more idea of a possible threat. Anyone else have one in mind?
So it's
Well,
not a threat. Sorry.
Okay.
It's not a threat, but I was just curious. Maybe it's a question for Chrissy and Cal, that how easy it is for either Keppel or ODK Collect. I think Keppel is the application who's going to do that, to index the fingerprint match from a pool of 10,000 or 100,000 fingerprints.
I think it's a bigger challenge because ultimately it's an algorithmic process which is pairwise, so it's embarrassingly parallel. We benchmarked this on our original version where we were using JavaScript to compare one to every other possible fingerprint, and the comparison time is about 0.6 of a second per test. So if we had 100,000 fingerprints to screen to try and just blindly put a fingerprint on and find the correct match, you've got 0.6 seconds times 100,000 to find that. Now, parallel processing probably could speed that up if that was even possible on the app. But in reality, it's a problem that scales, and so there's no rational solution to it that's going to make that work. I think in the short term, at least. I think if we took another approach, we might be able to do it, but certainly not with the approach we're doing. I'm not sure what Cal thinks about that.
So what's the limit, if any?
Well,
1,000.
currently for on
10,000,
device,
yeah.
you're passing the data to Keppel. So if you're passing 10,000, you'd have to pass 10,000 strings through to Keppel, and there's no way your Android phone is going to like that. It will just explode. So I'd imagine it's more in the tens would be the limit it could handle right now.
Yeah, I think the coherent
on
use
device.
here is that you might have all 10 of a person's fingerprints from a previous encounter, and they're able to put any finger on the reader and it will identify who they are, as in it will confirm who they are. The nice thing is that if you get a poor match on one finger, because for instance you've abraded your fingerprints, you can put the next finger on and it will still confirm who you are. It's much nicer than having to collect a whole bunch of fingerprints every time and doing like a 5 for 5 match, which is totally possible. But doing a one against many is nicer than doing many against many, because it saves time, because you don't have to keep doing this every time like you do when you go to the US Customs.
We'll link to some other biometric systems that are compatible with Collect that do the match that you're describing. Those usually have to have some kind of pre-processed data set within their own application so that they can do that match quickly. So it's sort of more infrastructure. Usually those are more expensive. You'll have some kind of costs, a recurring cost to manage that data and to make those matches quick. I think the advantage of this system is you can use off-the-shelf software because everything is hashed. There is some element of security, and it's very transparent. Like Chrissy kept talking about reproducibility. If you actually keep the hashes that you collect in the field and the ones at registration time and at follow-up time, then you can validate that match later on. So there's a lot of nice properties to it, but there are other systems that have other approaches. So in the interest of time, I'm not going to talk through these threats and mitigations, but I encourage you to check them out and see how they might apply to your project. I'm going to hand off to Yao, who's going to talk a little bit about some of the software level considerations. We do this kind of threat modeling ourselves with every single change that we make to ODK, and we consider what are the usability trade-offs, how can we increase security? So over to you, Yao. I'm going to stop sharing and then make sure you unmute.
All right, there we go. I'm going to share. Everybody can see my screen, presumably.
Oh, we can see everything.
Ah, I see. Well, it's always like that, huh? All right, let's see. Is this better? Hopefully this is better.
Yeah.
Yeah, cool. All right. As always, that's the last person. I'm always forced to compress my words of wisdom down into short bursts of wisdom, but we do want to facilitate as much discussion as possible. Thankfully, a lot of this information is out there already. So I will start to say that, ODK, over the last 16 years, we've tried to offer industry-leading security to sort of protect some of the data you collect. Some of it is like automatic, like we do a lot of vulnerability scanning in the code. Others is configurable, like end-to-end encryption, so you can sort of configure it to strike that balance that you want. And then when it comes to security, it's like super important for folks to be able to verify claims, right? That's one of the perks of ODK. It's 100% open source, so you can freely audit what we say is true. That said, not everybody is like a programmer, and so we spent a bunch of time putting together a bunch of resources that are more easy to use, understandable, so you can guide your decision making. So I want to dig into that. That page is going to be at docs.getodk.org/security. We just published it like yesterday, but don't click on it now because you'll spoil the surprise I have in the store for you. So we've been talking a lot about threat modeling. So I want to just share some context about ODK. So since the project started, we have had no reports of unauthorized access. We've also had no security breaches on the service that we maintain. So just like an upfront about that. The kinds of reports that we typically get where there are problems, security problems, or things that could be perceived as security problems is like data collectors. I wrote cheating. Lightly trained data collectors not doing the correct thing. Data leaks from people like posting their CSV exports on forums, and then issues that are from automated scans. I want to touch on that last one, the issues from automated scans. There are a lot of security scanners like in the world, and so they'll scan a website and tell you whether or not it has security issues. These are not always valid because we have to think about the goals that ODK has. Our goal is to build a platform that is usable by a bunch of users who don't have a lot of technical capacity. They have a bunch of different workflows, and so we have to make a trade-off between like what a automated web scanner thinks is secure versus the problems that we're trying to solve. So let me give you an example. If you scan the ODK Collect mobile app, it'll tell you that we sometimes offer HTTP as opposed to HTTPS. And this is definitely a security issue, but a lot of our users want to be able to collect data in an offline setting where HTTPS is not possible. They want to use devices that are much older for cost reasons. And so our job is to sort of default to secure, give people the option for things that we feel like are not that risky, and let users sort of make that trade-off. The real threats that we consider are these, and this is also on the website. People pulling data off devices, people sharing their credentials, people getting unauthorized access to the data, people creating fake data, privilege escalation where you give somebody like a project viewer access on the server and somehow they're able to get administrative access, and then just malicious actors, hackers, bad people trying to get access to the servers. For each of these threats, we try to put mitigations in there. So for example, for malicious actors accessing data from the mobile device, like that's why we recommend that people have device biometrics, or for people for data collectors accidentally getting access to full data sets. That's why there's that separation between web users and app users. Like data collectors can't get access to any sort of management things. So these are the threats that we consider when we're adding features and improving ODK. And again, we document this in the docs page so you can see it and learn more about it. I want to keep the good times going. Some recommendations and considerations given these like threats. Before I do that, some of these, like the second one, data collectors sharing their credentials with others. This is also like not a black and white issue. So for example, like there's some projects where it's really important to create a group account that are shared between users. And so technically that is sharing credentials. So that's why like we do things like have the QR code system where you can choose whether or not you want your data collectors to like have individual auth or shared auth, and you have that flexibility there. We try to share those trade-offs with people. Okay, so I'm looking at the time. I still got time. Okay, let's talk about, given these primary threats, which again are documented in the docs page now that you can read more about, what are some recommendations? I'm going to start with the device recommendations. We've talked a lot about these. You got to be using the latest version of Android. You got to have a strong passcode. We recommend you use HTTPS to keep updates on, and then you turn on encryption. So if you do these, your device is going to be in like the device side of your security is going to be in pretty good shape. We also do have these protected settings, like the admin settings in Collect, where you can hide things from users. For example, if you don't want users to be able to edit data after the fact, after they collect it, you can adjust that in Collect. So these are just like high-level device recommendations to sort of reduce your risk on the mobile side. The server side is a little more complicated. And so we have what I'm calling sort of hosting considerations to keep your data safe. Ultimately, like the infrastructure that you run on has a huge impact on, on the security of it. And so on the we have like a whole list of hosting considerations. These are just like a sample of them. And in particular, I break this down as far as like ODK Cloud and self-hosting. So for example, like ODK Cloud is not a server on your desk. It's like super robust infrastructure, isolated CPU, RAM storage, and just a bunch of security stuff that we do. There's no database access. There's no external SSH to keep the servers safe. So there are things that differ between ODK Cloud and self-hosting. At the same time, a lot of stuff that we do in ODK benefits whether you host on cloud or not. So for example, a lot of like the code and container scanning, the automated testing, the verifications that we do are all broadly available. So when you're thinking about a platform to host on, if you're self-hosting, you want to make sure that everything that is like a question mark, that you take care of these kinds of things, because not doing so puts your data at risk. Probably the biggest, you don't see this in this list, but the biggest is like keeping the software up to date. Like if you have an install of Central from like 3 years ago, it's running vulnerable code. Like every software is running vulnerable code. The longer you let it run without updating, the more vulnerable it is. So it's like the biggest thing that you can do is just make sure that the software, both the OS, Central, Docker, all that stuff is up to date. And again, we have all the stuff documented so you can see it. I mentioned penetration testing. Most self-hosters don't do penetration testing, but we do penetration testing on cloud. And these tests test things like the OWASP top 10, so access control, crypto, injection attacks, those kinds of things. And we do effective a couple of days from now, hopefully, we'll be sharing the results of these independent tests. So these tests that we do are white box penetration tests. That means the attackers, some very nice Germans that we worked with, the attackers have access to all the ODK source code. They have access to like the infrastructure more than other attackers will do, so they can really give their best go. They also look over obviously the source code and review both our process and our architecture. So we did a pen test, I think it was started in July, and we'll be sharing those results soon. It's our hope that we continue to share sort of these public results of these pen tests. So that's something that you should know. If you are self-hosting, we got some best practices that you need to consider. Your servers are constantly under attack. You may not see, but they are. One of the best things to do is if you have a few hours, set up a Linux server, plug it onto the internet, and just look at the logs. It's just like attack. The moment it gets plugged into the internet, it's just automated attack after automated attack. So threats and vulnerabilities are always evolving. So if you're self-hosting, really, really important that you have a rigorous process for keeping the OS, Central, Docker, all those things up to date and patched. The second is just limiting server level access. Like if it's a shared server or if it's on your network and you're using SSH passwords, all these things can be very dangerous. And so you want to make sure that you do as much as you can there. And then the last thing is security is not just about like protecting against hackers. Like if your server goes down or if your backups don't work and data collectors are not able to collect the data and decision makers are not able to make decisions, that's functionally equivalent to being hacked. And so you want to make sure that like you work hard if you're self-hosted to make sure that you're not just only you backing up your stuff, but you're verifying that the backups actually work. You're doing that on a frequent enough basis, and that you have high availability. So these are just some best practices there. Usage independent of where you host, whether or not you know your software is up to date. There are some just practices in ODK that you should know about. So first, that it's always a trade-off. You know, the maximum security is not a very usable system, and the most usable system is often not the most secure. So you have to be doing the threat modeling, understanding those risks, communicating that to the stakeholders of the project to make sure you have that right balance there. Some like 3 things that you can think of. The first is that your QR codes are sensitive. They have the auth that lets your data collector send in data, so you want to keep those safe. If you're in a large enterprise where you need things like a multi-factor auth, we do have single sign-on that's available that you can use to have an identity provider that you control, and you can control password restrictions and whether or not you use 2-factor auth. You can do that with SSO if that's something that's important to you. And then sometimes you're collecting data on infrastructure that you don't trust. So for example, I'm going to call out Chrissy here. LSHCM has a bunch of servers. There's a bunch of studies being run on the servers, and Chris is a very nice person, but IRB may not allow a study running on the server. IRB may not allow, even though Chris is administering the server, to see that data. And so we do have form level and project level encryption in case you're doing data collection on infrastructure that you do not trust. Frequently asked questions, and then we'll wrap things up. For the penetration test, one question that we've already started to get is like, how does this apply to like ODK-based systems? Everything on the security page applies only to software that ODK controls. So ODK Collect and ODK Central and ODK Cloud. Other platforms we have no control over. We have not penetration tested. So all these different ODK-based platforms make different trade-offs as far as what features are important, performance characteristics, security characteristics. So if you're using an ODK-based platform, this security stuff doesn't necessarily apply. And so you should, if you're using a different platform, you should ask for their penetration tests and ask for their security policies and practices. That way you can make the best choice there. What about automated security scans? We get these a lot, questions about this a lot. We don't find automated security scans always relevant because they don't take in consideration the context of the platform that we're trying to solve. I mentioned like the Android example. Oftentimes people say like the session timeouts in ODK are too short or too long. These are all design trade-offs. And actually, as part of the penetration test, we made sure that the independent party that did the penetration test considered all of these kinds of things and try to find the right balance and share their independent assessment of those kinds of things. So we don't take the security scans stuff too seriously because it's context-free. The last thing, and then I'll stop talking because time's out, is if you find a security issue in ODK, we have a security email, security@getodk.org. This is also on the security page, and it explains how you can responsibly disclose any issues that you find. We have a, respond to security issues very, very quickly. I think we have a guarantee of 3 business days. It's usually a lot faster than that. So that disclosure page that you can find on the docs.getodk.org/security explains how you can responsibly report a security issue so we can have that fixed. Resources, this will be in the slides, the cheat sheet, the privacy tips, and then the new security page that has the threat model stuff we talked about, the hosting stuff, the device stuff, security audits, responsible disclosure, and so on and so forth. So I didn't look at any of the chat, so I don't know if there's questions. Hopefully Alen and Ali have been answering those questions, but I'm going to stop sharing my screen and see if there are any questions that are like involve me and that have not been answered. Saad has a question about whether or not we can do, so we don't do penetration testing because incentives don't align, right? We are if we do a penetration test, we say, oh, everything looks okay. So we don't try as hard. We find, and best practice is that you need to pay somebody who does penetration tests who is independent from your team, who can do a good job. So that's what we've done. And so there's lots of penetration testing firms out there. I'll be honest with you, a lot of them are not very good. We found a very good one that we like. And so when we post a report, you'll be able to reach out to them and do that penetration test. It's definitely a service that penetration tests, I think, are like not inexpensive. I think it's hard to find a good one for under $20,000, to be honest with you. You can find lots of bad ones for less. So it's an expensive service. But if you really want a vigorous look at your security, that's what you need to do. Will we trust you? Yeah, trust but verify. Even if we have the best intentions, we make mistakes. We take security very seriously, but we make mistakes. And so that's why it's really important to pay somebody external who can just really, and not a bot, like a human being who's very creative, has malicious intentions, and can really like hammer on your system to make sure that it's actually secure. All right, I think that is it. Next steps. We're going to skip product updates. Ali, do you want to take on next steps? Or should I?
Yep.
I can do that.
No, I can as well. Sorry. Yeah. Oh, great. Great.
Yeah. So next steps, we will update the security page with the audit results. I don't know what screen people are looking at. Hopefully it's not my horrific screen. Oh, it's a good one.
It's good.
Awesome. If you're interested in doing a lightning talk, reach out to us, Ali or myself or Len, and we'll schedule one. The next call will be in December, and we're going to be workshopping some geospatial question types in web forms. This one is going to be fun and really important to get data collectors there. So if you have data collectors, they are one-time only opportunity to participate.
No.
All right, Ali said no. Okay, it's a
No.
first time inaugural opportunity to participate in the design process with the core team. So if you have data collectors who collect geospatial data, please have them participate in this workshop that we'll have on December 7th. It'll be like an early Christmas gift. So I'm going to hand things over to Ali. I think we've got after hours, right, Ali?
Yeah, it's just open space. If anyone has questions, we'll stay on for like another 15 minutes.
Awesome. So if you have to go, thanks for
It's
coming.
all right. Yeah.
It was awesome. And hopefully we learned a bunch of stuff about security. If you don't have to go, we're here and we can answer whatever questions you have.